Okay, hello everybody. My name is Ehsan and welcome to lab number 3, electrical drive. So by end of this lab you will be familiar with three-phase variable frequency induction motor drive. And the main objective of this lab is actually the measurement of RMS value of the fundamental frequency component in the voltage at the output of three-phase PWM inverter, and also we need to see the effect of frequency on saturation in an induction motor. To do so, we need to build this circuit first. So as you can see, this is the variable frequency induction motor drive including three-phase filter. So if you back to the circuit, basically we need to measure the voltage of between the phase number A and B before filtering, and also the voltage after filtering. So what we have here, we have three-phase voltage here, rectifier, inverter, and also three-phase filter. And this is your induction motor, and this is your brake. So how we now we have started the wiring of this for this circuit. Here that's your rectifier, and here you can see the chopper, and this is your three-phase filter and also your induction motor. So I have done the wiring. So now what we need to do, we just need to go to the software part, and we go to data acquisition and control interface. We need to look after this one, chopper or inverter control. So there are a couple of settings we need to do here, like we need to introduce this interface PWM inverter, and we need to follow this step. We have set the switching frequency up through 3000, and the phase sequence should be like this one, phase number 8 to 3. So you need to be careful about that. And the frequency here is set to 15, and that's all the settings. Okay, so now what we need to do, we just need to start PWM here from this point. So once I press the start, so this one should be run as well. Alright, so now the induction motor is running. So what we need to do, so now we need to see the waveform in oscilloscope just to give you the idea what's the impact of that changes in the output in before and after the filtering. So in this window, what we need to find is just the oscilloscope. All right. So we had 3 channel or 4 channel. One channel for just to monitor the voltage number 1, E1, and channel 2 is your voltage before filtering, and channel 3 is actually the voltage after filtering. And also, in case that you want to see how the current waveform looks like, so we have done this. We have set channel 2 to see current as well. So now the yellow one is actually channel 1 or V1. The green one, as you can see, is the voltage before filtering, and the purple one is, if you can see that, so it's actually your voltage after the filtering. So I provide you with this graph later on, and then you need to analyze the circuit based on these values. And the other thing you need to do also is about the harmonic. So here in this part you can monitor the harmonics as well. So this gives you the idea of how I have set the frequency for up to 40 harmonics, and here you can see the voltage after the first harmonic, second up to 40. So there are a couple of questions for you guys. You need to go to, based on this data that I provide you with those things, so you need to analyze the circuit again and answer the question. So this is pretty much everything about first part for lab number 3. There is another part, so I'll go through this one in the next video as well. Okay, so in part B of lab 3, so what we have done, we just removed the three-phase filter. As you can see, there is no filter here. So what we need to do, we just need to monitor the voltage of output side of the rectifier and also the voltage after the inverter. So we have done the wiring in the circuit. All I did, I just removed the three-phase filter from this side, but the setting is just remains same. So I start this part. So I run the induction motor from this part, and now all I need to do just to see how the waveform looks like, I go to the oscilloscope side. Okay, I go to the oscilloscope. As you can see, channel 1 is set to monitor the voltage of the rectifier. Channel 2 is set to monitor the voltage of the inverter, and this is your current. So all details given here, so you can see the RMS value of channel 1, channel 2, and also the current as well. So all you need to do, just you need to keep the record of this data. I provide you later on during the Zoom meeting, and then based on these details, so you need to answer the question as well. In part C for lab 3, now we need to study the effect of frequency on induction motor speed. So the wiring will remain same as the one we have done in part A and in part B without filtering. What we need to do, we need to do a couple of settings on software, and then once we're done, we need to change the frequency, and then we need to record some data. For the frequency, we are asked to set it to nominal frequency. In our case, is about 50 hertz, and then we need to increase the frequency for this value, 4/3 of the nominal frequency. So in our case, it will be something about 66 hertz, and then we need to gradually decrease the frequency for half, and it will be 25 hertz. And then for that part, we need to record those parameters. Now back to setting here. This is the oscilloscope. For the dynamometer, we need to set the torque control to the knob. In that case, we are allowed to change the torque manually. It gives us the possibility to change the torque manually. And then also for IGBT part, we need to do this setting. We have changed the function setting to the three-phase PMW inverter, and as I mentioned in the previous part, phase sequence should be in a forward one, and sequence should be phase 1, phase 2, phase 3. And we have set the frequency to the nominal value, which is 50 hertz. So the input is also sinusoidal. What we need to do now, we need to start our induction motor from this part, and then we need to go to the oscilloscope section and monitor the values. So this is what I'm doing now. All right, so now induction motor is running, and I have set the input to channel number 1 to monitor DC bus E1, and I set channel 2 to current based on these values, right? Now if you look at the values here, RMS value and the average value, you need to monitor those values, and then you need to write those values that you can read here on the table that I mentioned earlier. So here, this is the data that we need for nominal frequency. Now what I need to do, I need to change the frequency, increase it gradually up to 4/3 of nominal frequency, which is about 66. So I go to IGBT section, I need to change the frequency, but you need to be careful here, I need to increase it gradually. I set it to 55, and the target is 66, right? And then 60, and then 66. All right. Here you can see the speed. Can you move here? Here you can see the speed for that frequency, which is 66 Hertz. That's the speed, that's the power, and that's the torque. Now while you are here, I just move back to nominal frequency. I just gradually decrease the frequency for nominal one. Before I go to the next step, here you can see the RMS value for channel 1 and channel 2, which is the voltage and the frequency, the current. Now what I do, I just change the frequency to the nominal one. And while I'm decreasing the frequency, you can monitor the speed as well. Okay, I decrease the frequency from 66 to 60. Now you can see the speed, and then next step 55, and then back to the nominal frequency, which is 60 Hz. Alright, so now you are monitoring the speed and the torque and the power. So now what I need to do for the next step, I need to decrease the frequency gradually for half, which will be 25 Hz. So I decrease it from 50 to, for example, 45, and keep going up to our target. This is 45. This is 40. This is 35. This is 30 Hz. And last step is 25. Okay, here you can see the speed and the torque and the power for that frequency. And back to the oscilloscope. Back to oscilloscope, you can see the RMS value for the voltage, DC bus, and also the current. So by reading those values, you can actually feel the table sitting here. the table sitting here for the frequency, for these three frequency. We have monitored the speed, DC bus, RMS value, and also the magnitude. I provide you with the details, with the data, but this is how we can do part C of lab 3. Okay, so this is the last part of lab 3, which is called saturation curves. In this part of the exercise, you will plot the saturation curve of the three-phase induction motor at 4 different frequencies. Nominal frequency, 2/3 of the nominal frequency, half, and 1/3 the nominal frequency. What we have done so far, we just removed the, here you can see the table that we need to fill in. We need to record the data, the voltage and the current, the maximum current for this frequency, fundamental or the nominal one, which is 50 Hertz. Next one is 2/3, half, and 1/3. To record the data, we need to change the peak voltage by changing from 117, which is the maximum, up to 30. How we can change this setting? You need to come to the IGBT section, and here you can see the peak voltage, percentage of DC bus. So from here you can change the things. By the way, to do this lab, first of all, we have removed the belt of the induction motor, and just to prevent overheating, I just try to minimize the recording. So for that, I just try to show you how you do how to record the data for maybe 2 or 3 samples, and then later on I provide you with the full data. All right. So first of all, I change the peak voltage for 170, which is the maximum one according to the manual. And I have set the frequency to the nominal one, which is 50 Hertz. I run the things, and then I just monitor the RMS value for the voltage and the current as well. So once I done the first part, then I try to change the peak voltage to some value in the middle, and then let's see what happens. All right, here you can see for the first part, which is the nominal frequency 50 Hertz and peak voltage is set to 170. Here you can see the output, the current and the voltage, and this is the value for RMS value for the voltage and for the current. For the next step, just to show you, just to give you the idea how we can do the thing, I just change the peak voltage to, for example, half, which is maybe 50 almost.
Half is 60.
That's fine. So 50, just to give them the idea. So for that part, you can see the RMS value for the voltage and the current. Again, the goal is to analyze the saturation curve. You need to plot the saturation curve. So you just follow the structure in the manual, and then you see what you need to do. Again, to prevent the overheating of the motor, I do one more example. I just change the frequency for the other part, which is, for example, 2/3. 2/3 of nominal frequency, in our case, is 33. So I change the frequency to 33, and randomly I just change the peak voltage to, for example, 80. Again, this is just to give you the idea how we do this lab and how we can plot the saturation curve. All right, that's the only thing you need to do. I run. Here you can see again the RMS value for the voltage and for the current as well. You need to be quick because of overheating, so that's why I stopped running this motor. And then you need to keep doing the same thing for just to fill this table for the different frequency and different peak voltage.